We're going to take a look at 3.2 where we left off in class. You should have your note sheets out ready. We were talking about measures of dispersion. That was standard deviation, range, and then variance. So you can have your book open at this time too, or just follow along. Um, so we left off talking about standard deviation. What is it? We answered some questions. And so this is where we left off talking about, from your notes, it should be in this area. So do you understand standard deviation? Which should be the question. What is that again? Standard deviation. To show it to you again real quick. Standard deviation. Standard deviation looks like this here. And so one of the first questions we asked about as we were looking at it is if you can look at looking at a graph, which one has a bigger standard deviation. Remember, it's a measure of how spread out. It's a value that tells you how spread out the data is. And so we looked at this one in class. This one here is the smallest standard deviation because it goes from 48 to 56. The numbers are close together. There's more numbers close together. The mean would be somewhere around 52, 53, 54. And then the biggest standard deviation was this one here. As you can look, it goes from the 20, like 23 all the way to 123, or like maybe 13 to 123. So it's really spread out. So that has a bigger standard deviation. So that's what we had talked about. The mean here is also around 52, 53, somewhere in there. Similar, but they have different standard deviations. So that's what we were talking about. So question to consider real quick. When we measure and calculate standard deviation, can standard deviation ever be a negative value? The answer to that question, think about that. It measures how far from average all the values are, how far from the mean all the data set is. So when you're measuring distance, how far something is, the standard deviation can never be negative. So that is a true statement. Another question about checking for your understanding is create a set of values whose standard deviation is equal to 0. So really that question is asking, when would the standard deviation be equal to 0? And so here's a set of numbers. Let's see, I'll make them here. Here's a set of 5 numbers. A set of 5 numbers whose standard deviation is equal to 0. Why is that? It's because all the values are the same. If they are the same, then they are all the same distance from the average. So the average for this set of values is 1. How far are all these values? They are 0 away. They are 1. So the standard deviation would be equal to 0. That's the only time it would be equal to 0 is when, in this case, all values are the same. That's what will produce an equal standard deviation. True or false? The greater the variability about the mean, the larger the value of the standard deviation. Greater variability, it's a key word, that's a synonym. That's another word for spread, or another word, that would be another word for dispersion. That's just a synonym for those. So the answer to this case would be true. Greater variability. This one here I would like to probably discuss in class, but think about that real quick. Which quantity would probably have a greater standard deviation for a 40-year-old person in the United States? More than likely, if you asked a person that question, it would be harder to predict their answer. It's harder to predict their answer because on this one, because that's probably people have had more boyfriends or girlfriends in their life compared to spouses. There's more variability here in terms of the answer. There's more variability. And we learn variability kind of means spread or dispersion with the answers. Okay, so I want to check, that's where we left off. I'm going to introduce a quick concept, and then we'll look at an example in the next video. To finish your notes here, there's a third way we measure. A third way that we measure dispersion, spread, variability is through what's called the variance. We don't spend a lot of time in this class on variance. We introduce it here. It's for a future class. It's for a future class. But we introduce it and just give you a simple way to calculate it. The population variance, that's a sigma squared. If you look at the notation, that's a Greek letter. And the sample variance, in case we have a sample data, we just use an S, and that's a squared, like power 2. So that's the notation. So again, that is really, the variance is really just, if you want to make a quick note and you're, without being sure, just reading it, the variance is the standard deviation squared. That's all it is. So those are the symbols we use for standard deviation. Standard deviation squared. So that's all that is there. And so then what we have here is determining the variance. So it's real simple here. If you're given, in previous examples here, we considered the population. Okay, for this data, we computed the mean and the population standard deviation of 9.8. We then obtained a simple random sample, and we got these values, 80. And so we have the population, then we did a sample, use the population standard deviation score and sample deviation score to determine the population variance. So it's real simple. It's just the population variance, you square the population standard deviation. There's my sigma there. And so that would just be 9.8 squared. And then for the sample variance, you would just take that other value. Yeah, it's that simple. It's going to be 8 squared. So that would be 64. And I don't have a calculator in front of me. So 9.8 squared is equal to 9.8 squared. I'll let you check that out. Okay, so that's for review of standard deviation and variance.